Okay, so we just conducted a hypothesis test in SPSS to compare two population proportions, and we constructed a confidence interval for the difference between two population proportions, both which indicated that the difference between the two population proportions may be zero, meaning that the two groups may have the same proportion of low birth weight babies. So now we are going to move on to page 3, hand calculations. The main thing to see here is, I'm not going to go through these with you. The main thing to see here is that the values are calculated, the values which we calculated are the same. So the z-score here, as you can see, 1.79 is the same as SPSS obtained. Let's go to our output here. Okay, we see here our output 1.79, same value which we calculate by hand here. The other thing to notice is the standard error will be calculated differently next when we construct a 95% confidence interval. Remember, that's why when we look in our output, we look in different rows depending on whether or not we're conducting a hypothesis test. If we're conducting a hypothesis test, we look in the row equal variance is assumed for our z-score, our p-value. If we are interested in a confidence interval, we look in our row equal variance is not assumed to get our confidence interval. It's because the standard errors are calculated differently. So the main thing here is just to confirm that our z-score is the same as that obtained by SPSS, and our p-value, which we can get from SPSS, Excel, we can confirm is 0.074. Now another thing here to note is the rule of thumb which we use to let us know whether or not it's appropriate to conduct a large sample z-test. For hypothesis testing, we say we should have success and failure both greater than 5 for both groups. I have it here in Excel worked out for you, just to confirm that that is the case. They are both greater than 5. How did I get these values? If you look in the cross tabs for SPSS, we saw that the two groups which we were comparing, mothers who smoked to mothers who did not smoke, the response variable we were interested in was the proportion of low birth weight babies. So for mothers who did not smoke, the proportion of low birth weight babies would be 55 over 684. So that's for mothers who did not smoke. So if you see here 55 over 684, that's 0.08 or 8%. And the proportion of babies who were not low birth weight, 629 over 684, or 1 minus p, which is here, 1 minus 0.080409. Now successes and failures, remember n times p is successes. We see 55 here, n times 1 minus p, 629. Now that is definitely greater than 5. Now the other group, those who smoked during pregnancy, the proportion who were low birth weight, 15 over 114, so we see that here, 15 over 114. The proportion babies who are not low birth weight, 1 minus P, or 99 over 114, which is 0.87, about 87%. Now successes, again, NP will give us 15, failures 99. So for both groups, successes and failures are greater than 5. That's the rule of thumb for conducting a large sample z-test when we're comparing two population proportions. And so we calculated a z-score, and we can get the p-value for that z-score using our norm dist. Remember, our z-score is 1.79. Standard mean, standardized normal distribution has a mean of 0, standard deviation of 1. And we would like cumulative. Now what is this telling us? This is telling us the cumulative probability up to a z-score of 1.79, which is telling us to the left. We want to the right, so we do 1 minus that to give us this. Now this is one tail, this is the right tail. We're doing a two-tail test. So what are we going to do? Multiply this value by 2 to get 0.073454, which is basically 0.074, which we got in our SPSS output. So now that we've confirmed the results of our hypothesis test, we're going to confirm the results of the confidence interval calculated by SPSS. Now again, I'm not going to go through this too much. You can go through this on your own, but the main thing here is just to confirm that we get the same values, and also note that the standard error is calculated differently when we are calculating a confidence interval. Also, the rule of thumb when we're calculating a confidence interval is that the successes and failures should be both greater than 10 for both groups. Recall it was greater than 5 when we dealt with a hypothesis test, and it was now when we're calculating a confidence interval, its successes and failures should both be greater than 10. This is consistent with what your text says, so we can go by that. In this case, we saw before both were greater than 5, and also they both were greater than 10. So that's fine. We can assume a normal sampling distribution. We calculate our standard error, and with that we can calculate our confidence interval. And as you can see here, our confidence interval, which we obtained from SPSS, remember we looked in our row equal variance is not assumed. Now look at the standard error, 0.033, which we calculated, and the confidence interval is consistent with that. A little bit of rounding, we have 0.117, 0.115 here. It's consistent with that, which was obtained from SPSS. Again, 0 is within that confidence interval. So we've confirmed our hand calculations match that obtained by SPSS. So we've learned two things here. We've learned how to compare two population proportions, and we've learned how to construct a confidence interval for the difference between two population proportions. And finally, we learned how to interpret those two analyses. Next, we'll learn how to compare two population means and how to construct a confidence interval for the difference between two population means.